Hello everyone, this is Rui PCB, your trusted PCB partner. Today we will introduce the commonly used PCB parameter settings in KiCad. The ultimate goal of circuit schematic design is to produce a PCB that meets your requirement. With KiCad software, it's very easy to transition from schematic design to PCB design. PCB routing is the most important and time-consuming part of the entire PCB design process. You could say that all the previous work is done in preparation for it. In the entire PCB design process, it is essential to be familiar with the PCB design workflow. In KiCad, a printed circuit board typically consists of component packages and pads, which represent the components and their solder points. It also defines how these pads are interconnected into nets, forms the routing vias and copper ports that link paths within each net, and includes various graphics and shapes that define the board edge, silk screen markings, and any other necessary information. KiCad usually keeps the net information on the PCB synchronized with a corresponding schematic, but it is also possible to create and edit nets directly within the PCB editor. When drawing a PCB, whether the system tool settings are reasonable directly affects whether the software's functions can be fully utilized during the design process. By executing the menu command Tool Settings Preferences, let's take a look at the Settings Preferences command. You can open the Preferences window or press Ctrl plus comma. After opening it, we can see that on the PCB editing, there are 6 options: display options, grid options, origin and axis, editing options, color options, and participation. Let's go through them in order. The first one is display options. The first item under display options is the rendering engine, which, just like in the schematic, has 2 options: hardware acceleration and software compatibility. Choose according to whether you have a graphics card. If you do, select hardware acceleration for a smoother design experience. The grid display style is the same as in the schematic: dots, lines, and small crosses. By default, it's set to dots, so you can see a lot of small dots. Let's take a look at the difference between dots and lines. I personally don't like to use a small cross, so I won't introduce it separate. Just choose whichever you prefer. This is what it looks like in the line mode. Why do we use lines in schematics but dots in PCB design? Because in PCB design, we need to connect a lot of traces. And if we also draw a lot of lines for the grid, it can interfere with our analysis and observation of the traces we've drawn. So here, I recommend using dots or small crosses. I choose to use dots. As for grid, line width, and minimum spacing, we'll just leave them at their default settings. For grid snapping, we'll keep the default setting, which is always enabled. The difference between always enabling grid snapping and not enabling it is that with grid snapping always on, if you look at our cursor, whenever we move it, even just a little, it jumps by 1 grid unit. The advantage of this is that when I move components, everything moves according to the grid units, making it very easy to align components. Now let's look at the state when grid snapping is disabled. If we choose not to snap and first observe the cursor, it can move freely between any 2 points. However, when we try to move components, it becomes very difficult to align them because each movement is too small. That's why we generally use the always snap option. Next, for the cursor, you can choose between a large cross, a small cross, or the same as in the schematic. I personally prefer the small cross. Then, should the net name be displayed on the pad? I'll just introduce the option for not displaying and for displaying both. Let's first look at the state where both are displayed. If we draw a line, you can see that QF is the net identifier, and it appears both on the pad and on the line. This way, if the line is long, it's easy for us to analyze which net each line belongs to. If we make modifications midway, such as adjusting the line width or the position of the line, we can also clearly see what we are adjusting. If you choose not to display, select Do Not Display. Then you'll find that neither the pad nor the line shows the net name. In this case, when we draw lines, we have no idea which net we're working on, which makes it difficult for you to analyze errors and maintain the correctness of the routing. This is especially problematic when certain traces have special requirements for width, length, or impedance. If you don't know what you're drawing, you can't ensure its correctness. Therefore, we choose to display both. Alright, for the next few options in the middle, such as outline spacing and highlight selection, we don't need to worry about them. Just use the default settings. Next, let's talk about cross-probing, which is worth introducing. The first option is to highlight the corresponding object in the schematic area when selected. Let me mainly explain this point. Let's see what it means. For example, let's exit the Discovery tool and select U1. After selecting U1, let's look at the schematic. The U1 in the schematic will also become selected, so we can clearly see which component we've chosen. For example, when we're designing the schematic or PCB and notice an issue with a component that requires a net modification, we can simply select it and have it appear centered and highlighted by default. This makes it easier to accurately locate each component, whether you're navigating from the schematic to the PCB or vice versa. Since there are a lot of settings options for this PCB, and they're very important, we'll cover them over several episodes. So in this episode, we'll first finish introducing the display options. If you thoroughly enjoyed watching this video, please consider subscribing to my channel for more content. Thank you very much, everyone, for your continued support.